Hi, welcome. So this is the third segment of the four videos that I'm making on sequence and series. Let me make this bigger. In this segment, we're going directly into questions. If this is the first time that you're joining me, please go and watch the last two videos. They have the same title. The only difference is I put part one in the first one, then I put part two in the second one. Watch them before you get to this part. If you do not need them and you just want to go directly into um into the third segment, then you're more than welcome to. But in this, I'm just going directly into questions, having the assumption that you understood the concepts from part one and you did the questions from part two. All right, so let's go through this part. Here we have simple sigma questions. Find the sum from I equals 1 through 5 for the term 2i plus 1. So again, if you watch the first video, you know that, let me get my pen, 1 second. You know that all you have to do, the hint that I'm going to give you is this. You're going to plug 1 wherever you see I for the first term. So 2 times 1 plus 1. And then the next one, then you put a plus. Then you move on to 2. Then you plug 2. Then you move on to 3. Then you plug 3. And then it goes on like that. Basically, it goes further. All the way until you get to 5. This one, this is not a tricky one, but it's funny. Let me know what you think about question 2. If you can't solve it, then it's actually a very simple answer. Let's see. Pause the video here. Take time to solve both questions. Do not move on. Solve them before you move on, and then move on to the next slide. And then play the video. I said move on to the next slide and play the video. Then you see the solutions for both questions. All right. So here's the solution to the first one. Again, it's pretty simple. Let me get my pen out. Where you see where I is, what does I begin with? I begin with 1. So you plug in 1 right here. Then what's next after 1? 2, because our goal is to go all the way to 5. Then you plug in 2 here, because that's where I is. You see that? That's where I is. Then you plug in 3. Then you plug in 4. Then you plug in 5. That's where I is through all of them. It goes on this way. And then you combine it. 2 times 2 plus 1 is 3. 2 times 2 plus 1 is 5. Notice that they are all odd numbers, right? You add all of them, you should get 35. Pretty simple problem. If you're lost, go back to the first two videos. I think you'll be able to solve this question after watching the first two videos. If you watched both videos and you still not get it, leave me a comment and I'll get back. Next one. Told you it was a very simple problem. Find the sum. Here, there's no I. Let me get my pen. There is no I here. So if there's no I, there's nowhere to plug 1, 2, and 3. Because there's nowhere to plug 1, 2, and 3, you have to do the sum how many times? 1, 3 times. I equals 1, plus I equals 2, plus I equals 3. 3 times. So here's I equals 1. I equals 1. Here's I equals 2. Here's I equals 3. Because there's no I here. That's why. So you're summing it 3 times. 10 plus 10 plus 10, 30. Check. Again, tricky question. Well, for some people it might be. Let's move on to the next set of questions. So we're still in the third video, but second segment. All right. So here it says, now I'm giving you the sums. I'm saying find the sigma notation. Now, if you don't understand what I'm asking you, I'm simply saying rewrite this to make it look like this. Each of them, rewrite it to make it look like this. This is what I'm asking you for both. For this, do that for that, and do this for that. Now, the hint that I'll give you is take a look at this pattern. 1, 2, 3. It goes all the way to 9. Same thing. 1, 2, and it goes all the way to 15. Again, think about how to do them. They're very simple. rewrite them in the sum notation. Pause the video here, take time to do it. Once you're comfortable, play the video back to see the solution. Again, so here's the solution. This is very simple. Notice that 1 and 3 repeats everywhere. You see that 1 and 3? It repeats right there, right there. So if it repeats, then I'll just keep it in the formula. You see that? The only thing that changes the 1, 2, 3. It changes all the way to 9. So hence, I know that I starts from 1 and it ends at 9. And where is the number changing? Right next to 3. So I put the I right next to 3. So I end up with 1 over 3i. Simple. Again, the same thing here. Notice the 5 on top stays and the 1 on the bottom stays. So I don't need to change it. Just leave it. Because they're the same throughout each term. 5 over 1, 5 over 1, all the way to the end. The only thing that changes is this. The 1, 2, 3, all the way to 15. So what am I doing? I just add the I to it. Because the denominator is increasing by 1. By I. Okay, I hope that was clear enough. Move on to the next one. Again, so here we have 4 sets of questions. They're really simple, not so difficult. Again, pause the video. Try to understand how to do these questions first. Once you have attempted it yourself, play the video to see my solution. Here we have determine whether the sequence is arithmetic. If so, find the common difference between them. So I'll let you pause the video to do it first, and then you can continue solving it. Very simple, shouldn't be that difficult. Let's see. Take a look at the first one. It says determine whether the sequence is arithmetic. If so, find the common difference. So take a look at number 1. Number 1 is going up by 4, 9, 14, 19, 24. So we can clearly see that this is going up by what? Think about it. The second thing as well. This is going up by 80, 40, 20, 10, 5. We can clearly see that this is decreasing, but by what? Again, you guys think about that. The third one, we are given a formula. We're given the algebraic formula for the third and the fourth one. So all we're looking for is the common difference. So to solve the third one, the hint that I'll give you is this. Get my pen. Start with n equals 0. When n equals 0, actually no, start with n equals 1. I apologize. You cannot have 0 in the denominator. Start with n equals 1. What does that give you? Find that out. Then n equals 2. Then n equals 2. What does that give you? Find that out. This is a comma, by the way. It's just, I'm using a Mac to do this. So it's literally difficult. Then next one, n equals 3. And all the way. Keep doing it until once you have like 5 terms, try to find the pattern, the common difference. Same thing for question 4. Do the same thing. I'm sure you see something come out. Again, once you have tried this, then you can play the video. So take a look at the first one. I didn't do the first 2 for you because I thought it was pretty simple. I can just give you the answers to this one. This one, the difference is 5. Common difference here is 5. So the common difference between each term is 5. It's obvious. 4 plus 5, 9 plus 5. The second one, the common difference is what? You divide them by 2. It's a geometric sequence. Here, this is an arithmetic sequence. So the second one is not. It's not an arithmetic sequence because you're dividing by 2. As you can see, you're not subtracting 20 or 40. You're dividing by 2. 82 is 40. 40 by 2 is 20. 20 divided by 2 is 10. 10 divided by 2 is 5. So this is a geometric. So this is not even arithmetic as the question is saying. So let's cross that out. Number one is arithmetic, where the common difference is 5. So number 3 and 4. Let me show you how I solve this. So I said this is not arithmetic and also not arithmetic. Why? Because I did the same thing. I plugged in 1. This is what I got. Plugged in 2. Plugged in 3. And all the... So now there is a pattern, but it's not an arithmetic pattern. We have the common differences obtained by adding or subtracting. We're going to talk more about this later, but this is not an arithmetic sequence. Neither is the second one. The 4 over here is also not 1. Take a look at how I did that. Plugged in 1 for each case. 1, n equals 1, n equals 2, n equals 3, n equals 4, n equals 5. There's clearly not a pattern here. I even try to show you that, let me get my pen, that this you multiply 4 to get 8, but this is 3, so this should be 2, but that's not the case. So again, this is not arithmetic, so this is not the same thing by that. So let's take a look at that. Observe that these are not arithmetic patterns. Let's move on to the next one. All right, so let's see. Okay, so this is the final question for this segment of the video. So it says here, determine whether the sequence is arithmetic. If so, find the common difference. Again, this is something similar to the first one, or did I just repeat? All right, so I repeated the first two questions. So let me cross them out. So ignore that. Let's just do this once. Find the formula A of n for the arithmetic sequence. That's what we're doing. Find the formula A of n for the arithmetic sequence. Very simple. Again, if it's an arithmetic sequence, then we know that there's a common difference. Here they're giving us the common difference. D equals 4 here. Here D is negative 2, 3. So here it's increasing by 4. Here is decreasing by negative 2/3. And they give us the first term in each case. So pause the video, try it out, and then you can look at the solution. You can play the solution to look at the. You can play the video back to look at the solution. This is the formula that you have to use. For those of you who want to try it by yourself, A of n equals A of 1 plus n minus 1 times d. Try that. Here is it. Again, very simple. I'm just plugging in the formula directly. Plugging A of 1, plugging d. And I get the formula, which is what the question asks you to do. The same thing here is what I did. Here A of 1 is 0, so there was no need to put the 0 in. Or if there's any questions, please let me know. Straightforward is directly simple. Alright, so I'm going to stop the video here, and we will continue in the next segment for the fourth and final part of the sequence and series. Thank you.